Our final speaker for today is Burkard Polster. Burkard is a mathematician who specialises in communicating the beauty, fun and power of real mathematics to audiences ranging from very young children to research mathematicians. As part of this mission, he's discovered and researched many unexpected applications of serious mathematics in everyday life, including juggling, which we're going to see today, balancing wobbly tables, optimal shoelacing, optimal rugby conversion kicks, ringing the changes, maths in the movies, ambigrams, Rubik's cubes, and many more. Burkard is the author of 8 books and writes numerous research articles as well. Together with his colleague Marty Ross, he writes the weekly Maths Masters column in the Age newspaper and also delivers the annual free public maths lectures at the Melbourne Museum. Burkard has collected his degrees from around the world. He's originally from Germany, where he studied pure mathematics, and he came to Australia via the US, where he completed a Master of Arts and visited New Zealand along the way. So we'll leave it to Burkard. Thank you.
This has to be out of the way. Right, so what do? Well, I look lots of different things, lots of little things. I look at kind of obvious things in everyday life, and try to find some neat math there. And so things I've looked at is shoelaces, for example, or origami, or magic tricks, or all kinds of things, really. And today I just want to give you an example of what I do when I look at something, what I try to get out of it. So something I've been involved with in the past, and which has been asked for today, is juggling. So I'm going to talk a little bit about the maths of juggling. All right, so here for the barbecue, and I think you're also here for the juggling, so I'll just show you some juggling. Okay, so here's some juggling. Let's look for some maths. So this is the basic 3-ball cascade. I mean, there's a bit of juggling maths here. If you look at the yellow ball, it actually traces an infinity sign in the air. Okay, I can return reverse directions here. I can make things go in a circle. I can make things go like tennis. All right, like this. I can make things go like simultaneously. Another infinity sign, another tennis. Okay, fireworks. Trickle down. Behind the back, Mills Mass. This is Burke's Barrage. I'm also Burke the juggler. This is Rubinstein's Revenge. This is something I just made up for you. This is windscreen wipers. This is the yo-yo. And this is robot drop, and a bit of a miracle. I need to see a bit more of juggling before we can look for the maths. So 4 balls, just quickly 4 balls. 4 balls looks like this. You can also make them in a circle like that. You can make them cross. I can make them go simultaneously, like so. And, and then finally, so for this one you get the black belt. It's 5 balls, right? So 5 balls looks like this. Okay. And I've got more balls. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8. Actually, I wanted to show you 9. All right, so I'm going to use these ones here. So with 9, you can't ask for any more, right? You're going to be happy? All right. So 9 balls, the main difficulty is to have to fit them in your hands. So let me try and do this in a mathematical way. All right, remember, you're all going to be impressed? All right, here we go. Okay, so where's the maths in here? Well, I'll just show you some numbers. So when I juggle to a beat. So I just count out the beat here. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. You can see the yellow balls going up on every one. 1, 2, 3, 1, 2, 3. So what that means is it basically stays 3 beats in the air. Okay? If I change to let's do it this way. If I change to 4 balls, it's going to be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. The tosses go higher up because they have to stay longer in the air. 5 balls, you can guess. Let's just focus on the yellow ball. It's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we've got different sorts of throws in here, corresponding to different numbers. So we, for example, have a 3, we've got a 4, and we've got a 5, and a 6, and a 7, and a real 9 is maybe somewhere up there. We've also got 2s, so you can do 2-ball juggling. It looks like this. Not very exciting, so usually just hold it like this. People are really impressed. And then there's 1-ball juggling. It goes like this. 1-ball juggling. And, believe it or not, there's 0-ball juggling. And you can actually, I mean, if you manage to throw balls back in time, you can actually have negative number juggling. It's a bit hard. I'm still working on that trick, but eventually. All right. So, so these numbers, when you now look at a juggler, you know, just somewhere in St. Kilda, for example, I mean, they will have blindfolds and they'll be on unicycles and they'll be juggling chainsaws and they'll be making all kinds of contortions like I just did. But at the core of every single juggling pattern are just these numbers, right? So you just look at a juggler and kind of slow things down. So the juggler throws something, and on the particular throw, he's going to have something for a couple of beats in the air. So it might be 3 or 4 or 5. So for example, with this pattern, that's the basic pattern, it's just always going to be 3s. It's basically going to be 3, 3, 3, 3, 3. Every beat I throw here is going to be a 3-beat throw. So if you look at it in some sort of time diagram, so you've got the beats, and on this beat we throw a 3, so that stays 3 beats in the air, and then it lands again, stays 3 beats in the air, it keeps on going like this, and in fact every single ball in my juggle does the same thing. But now I want to show you something where things are actually mixed together. So this is the pattern 4, 4, 1, 3. So 4, remember, is this kind of throw. A 3 is this guy, and a 1 is like this. Okay? And we're going to do it like this. So I'll show you 4, 4, 1, 3. It goes like this. 4, 4, 1. Okay? 4, 4, 1, 3. 4, 4, 1, 3. So just have a look at the middle part. So the red ball is actually doing 1, 3 here. Okay? So 1, 3, 1, 3. And the outside one's doing 4, 4, 4. So every juggle you can imagine, when you look at the core of it, the mathematical soul is just a little sequence of numbers like this. In this case, it's 4, 4, 1, 3. With the basic pattern, it's 3. Okay? Now, you know, so you found the numbers, you basically found the mathematical soul. Now you kind of take it apart, right? Take it apart. Now you want to find out, can actually any sequence of numbers be juggled? So for example, what's your birthday?
My birthday.
Yeah, my birthday, yeah.
16th of March.
16th? Mm-hmm. Okay, 16th of March. So it's maybe 1, 6, 3. Can that be juggled? You can ask. In the sense, on one beat I throw a 1. On the next beat I throw a 6. On the next beat I throw a 3, and then I keep repeating. Right? Can that actually be juggled? No. Okay. And so why do I know this? Why do I know this? Because we've done a bit of an analysis and we found that there's an algebraic way of just taking the sequence of numbers and manipulating it a little bit, and that tells me whether something can be juggled or it can't be juggled. So what are actually the problems? I mean, on the face of it, maybe everything can be juggled, but just quickly, one of the problems that you get is if you try to throw a 3 followed by a 2, well, what happens? After 3 beats, you've got a collision happening here. So both balls end up landing at the same time, and that's not so good. All right, so there's definitely limitations, and there's actually, you know, if you just make up a sequence of numbers and ask for the probability that it can be juggled, it's quite low. All right, then you want to do a little bit more. That gets you to, you know, like a simple diagram. Well, I'll just show you a couple of examples here first. Okay, a couple of examples. So there's 2 balls, okay, 2 balls. So 2-ball juggling, remember, looks like this. You just wait long enough, everybody's going to laugh. Right? Okay, the next one was 3-1. You already saw this one. Then you can do 3-1 in both directions. If you just change directions like this, that's 3-1-2. Now I've got 3-3-0 here. Let's just do it like this. So this is 3-3-3-3-3-3-3. I just get rid of 1, and then I do zeros here instead of the 1. Right? So that's 3-3-0. Okay, 4-0-4-0, it's just like this. So it's basically 4 balls with just one side missing. And then there's an interesting one here, 501, which looks like this. So there's actually 5 throws in here, so the black belt throws, but you're just using 2 balls. And there's heaps of other examples, like infinitely many juggling patterns, different ones. And if you want to know, well, what are good juggling patterns to actually put into my routine, well, then you unleash the full force of mathematics on it and look at this simple diagram here. And that diagram actually tells you everything you'll ever want to know about juggling 3 balls and putting together throws to heights 0, 1, 2, 3, 4, and 5. So if you can manage those throws and kind of you want to know how can I put them together in different ways, that diagram will tell you everything about this. I'll just show you how you find these juggles or these juggling sequences. So what you're looking for in this diagram is basically cycles. And here's one. So you just follow the arrows, right? So that forms a full cycle. And if you just read off the numbers on these arrows, you find a juggle. So this, for example, is 441 is a little bit like a U-shape kind of thing. So it's the force going up here and the ones happening here that looks like this. So there's 441. And well, here on that side, you just got a little cycle. It's just a 3. That's just 3, 3, 3. That's the basic 3-ball juggle. But you can also put both of them together. That's 4, 4, 1, 3. And that's actually the one that I showed you at the very beginning, right? So 4, 4, 1, 3 with things going up here and something going in a circle in the middle. And there's heaps of other ones in here. In fact, there's infinitely many patterns just with 3 balls mixing together throws from 0 to 5 together. There's another one, which is actually really, really boring, right? So nobody ever wants to do this. But what's really nice about this whole thing is it gives you a systematic way of enumerating all possible patterns that you might ever want to try. And then you can actually try them out in real life and see, well, is this something that I want to show my audience? Right? Okay, now jugglers care about this because it's a really efficient way of communicating juggling patterns. It's really good to find everything, to be comprehensive. Learning in pieces is really good. I showed you, eventually you want to black belt in juggling, and you can practice black belt throws by just doing this here, right? So finding good patterns to practice really hard stuff. Okay. But now, once you've really mastered all this stuff, what you really want to do is explore what's possible, or what would be possible if I was a really, really good juggler. And I just want to show you a couple of examples of this. So let's see. So this is a program that at its core has what I've been talking about. And what you can explore here is patterns or juggling patterns that a superhero juggler could do. Like everything here is according to gravity. So if somebody was actually fast enough, they would actually be able to do this sort of thing. So this is, for example, a 9-ball box. Right? So I've been practicing this. I'll just show you a couple of other things. So this is juggling 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Also a pretty nice one. They get crazier. What about this one here? What about that one here? All very good. Well, if that's not good enough, you get a couple of friends together, and this is called a torture chamber. And this is a star. And of course, you have to do this with blindfolds and on unicycles and. And just one more. Oh, this is a really nice one. So that's actually the jugglers. They're juggling, and while they're doing this, they're juggling themselves. They juggle like this, right? You can also juggle like this, so that the unicyclists go around like this. And then just one final one. So what I do when I don't do juggling mass, I go to conventions, and you see all kinds of different things happening. And one of the things you always see is this really, 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 really tall unicycle. And on that note, I think that's it for me. Thank you very much.